Oh, hello there. The purpose of this video tutorial is to show you how to generate a scatter plot in Excel and how to generate a linear fit to said scatter plot. So your Excel file probably looks something like this. You've got masses you entered in grams, then length of the rubber band or the spring in centimeters, and then Excel calculated for you the stretch of the rubber band as well as the force that the rubber band was exerting. So to generate a scatter plot, first of all, you just highlight this section here. So I'm going to just click and drag here up into the data points, and then go to charts, click on charts, then click XY scatter, then choose this one, marked scatter. So I click that and it's going to generate a graph right here, which I don't want. It's right on top of my data, so I'm going to press Control, click, and do Move Chart, and I'm going to move it to a new sheet, and I could call this maybe force versus the stretch delta L, and I'll call that for object 1. Hit OK, and then down here you can see force versus delta L. Maybe my sheet 1, I should double click that and change that to data. So there's my, and I'm just going to double click and move it there. So there is my my scatter plot of the data. It says a label here of force. I'll just delete that. Now it looks like a pretty good line, but I'm not sure exactly how good it is. So what I do is I click on one data point, it highlights all of them, and then I hit Control, click, and do Add Trend Line. When I say Add Trend Line, it adds one in for me automatically. Says line. I can choose type and I can choose a bunch of different functions, but it looked like a line, so I'm going to keep it as a line. And then options, let's do display equation and display r squared value. So I'll hit OK, and then right here you can see the equation and the r squared value, and I can click here and make that a little bigger so I can see it better. So there it is. So it says that the equation of this linear fit for my data is y equals 80.736x plus 0.2523, and r squared is 0.988. The r squared is a measurement of how well this least squares regression line actually explains this variation in the data. An r squared of 1 would mean all the data points are exactly on the line. So an r squared of 0.98 is actually a very, very high correlation. So that shows me that this line is a good representation of my data. Therefore, I can use this line to make predictions about how far the spring or rubber band would stretch given various masses that I hung from it. So that's how you do it. Then you go back to data and you do the same thing for the next one. So when you're done, you're going to have a bunch of these tabs down here for object 1, object 2, object 3. And I want you to focus on what's the same and what's different about each of those. So that's it.